Okay, so tonight we'll start you guys with graphing trig functions. So we're going to start with a review. I know you guys did sine functions last year, so just a reminder, y equals sine x is your parent graph of a sine function. And so we're going to go through just basics of graphing. And then throughout the next week or so, we're going to add in the transformations. So we're going to start with just basic sine, and then we'll add transformations in as we go. So to start us off, just so you guys know, I'm just going to use one graph for all three examples today. Or at least to start with all three examples. So some things that you might want to remember about sine graphs is that one, what we call period, or one cycle, goes from 0 to 2 pi. So on my x-axis, I'm just going to start by labeling 0 to 2 pi, and then my halfway point pi. The halfway point between 0 and pi, which is pi over 2, and the halfway point between pi and 2 pi, which is 3 pi over 2. And then I'm going to do my y-axis. Now remember, the y-axis we can count by whole numbers. It's only the x-axis that we count in radians. Okay, so I'm going to graph all of them on that one graph. So I'm going to start off with just the graph of y equals sine x, the parent graph. So if you ever are not sure how to graph, T-charts are the way to go. So what I'm going to start by doing is just plugging in each one of my key points from 0 to 2 pi. So 0, pi over 2, pi, 3 pi over 2, oops, forgot the over 2, and then 2 pi. Okay, so most of these, actually not most, all of these are considered our quadrantal angles, and we can find their values on our unit circle. So sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. 3 pi over 2 is negative 1. And 2 pi, we're back at 0. So what I'm going to do is graph those key points on my chart. So 0, 0, pi over 2, 1, pi, comma 0, 3 pi over 2, negative 1, and 2 pi, 0. So that when I connect them, I have my sine graph. So again, this one's called the parent graph because we haven't made any alterations to it. So what we're going to look at on the next two is I'm going to change just one thing. And we're going to look at what that one thing does to our graph. So we're going to be making comparisons to the green one in the next two examples. So our next one is 2 sine x. So what have I done? I've multiplied a number in front of my sine function. So again, we're just going to do a table of values here with our same key points. And we'll plug them in and see what happens. So I'm going to do this one in red. So sine of 0 is 0. So I'll get 2 times 0, which gives me 0. Sine of pi over 2 is 1. So 2 times 1 is 2. Sine of pi is 0. So 2 times 0 is 0. Sine of 3 pi over 2 is negative 1. So here I'll get negative 2. And sine of 2 pi is 0. So I'll get 0. So when I go to plot them, I get the following graph. So when we look at it and compare it, what happened? So what I noticed happened is instead of going 1 to -1, we went 2 to -2. Okay, we'll talk about what that actually is in a couple minutes. The last one I want to do on this graph is what happens when we put a negative in front of our sign. So I'm again using the same key points. And just going to put a negative in front of them. So this one I'm going to do in purple. So sine of 0 is 0, so -0 is still just 0. Sine of pi over 2 is 1, so negative, we'd get -1. Sine of pi is 0, -0 is just 0. Sine of 3 pi over 2 is -1, double negative makes it positive. And then sine of 2 pi is 0, -0 is just 0. So when we go to plot this one, what do we notice in comparison to the green one? Oops. So what changed? The main thing that I noticed that changed is instead of starting at 0 and going up like the green one did, it went 0 and went down to start. These are the kind of things that we're going to be learning the names of and how to tell what's happening before we graph so that we can predict what our graphs are going to look like. Okay, so I said I would get back to what we called this number right here. Sorry, I just realized that was really crooked. Okay, so this number in front, so when we had the 2 in front, we started at the same spot, but instead of going up 1 like the green graph did, we went up 2. That number in front is called the amplitude. Okay, what that means is that number is half the distance from maximum to minimum of your graph. So if we look at our graph again and compare the green, my distance from maximum, so here's my maximum on the green, and here's my minimum on the green. This total distance here was 2. So when I half it, my amplitude was 1. So that's why I had a 1 in front. But if we look at the red graph, we go from the highest to the lowest. That had a distance of 4. Well, half of 4 means we have an amplitude of 2, which is the number that we had in front. So that number that's in front is telling us what half the distance from the maximum and the minimum is. So depending on if it's a number other than 1, we can figure that out. So if I asked you what is the amplitude of each of these graphs. So if I gave you y equals 7 sine x, what would our amplitude be? It would be this number in front. And then if you were asked a follow-up question like what's the distance between the highest and the lowest, or between the max and the min, you would just double this amplitude. Another thing is your amplitude must always be positive. So even if we have something like -3/4 sine x, your amplitude is still going to be just the 3/4. Because that negative is something totally different. So when we had a negative in front, what happened to our graph? So looking between the green and the purple, the negative, instead of having it go up like the parent graph, it reflected it and went down. So it's the same graph as the green, just reflected over the x-axis. So the negative here in this problem would tell us that it's reflected over the x-axis, but it's not going to change the value of our amplitude. Okay, so tomorrow in class, we're going to do one more example of graphing with an amplitude as well as with a reflection. So that way we can get some practice on all three of those things within one problem. We'll also talk about some highest values and lowest values and how to read them from a graph. So right now, as long as you have a basic understanding of how to graph, and we'll go over the shortcuts, which I know some of you know already from last year, but we'll go over the shortcuts for graphing as well as some more amplitude questions tomorrow in class.